I'm Christy Slade. It's my great honour to be the President of the Royal Society of New South Wales. And while I'm here, I acknowledge the traditional owners of the land on which we meet, the Gadigal people of the Eora Nation. I welcome you all to the Royal Society of New South Wales and Learned Academies Forum, which is yet again being held most generously at the residence of our patron, Her Excellency. I thank the Office of the Chief Scientist of New South Wales for supporting the forum this year, not only financially, but actually personally, so it's a great joy for me. This is the 11th in the series, which draws together the Royal Society, the Learned Academies, and members of civil society to debate issues of pressing importance. And I should tell you that the last 7 of these have been recorded and are available on our YouTube channel. The forum's designed to cross disciplinary boundaries to allow a broadly based, informed and civil discussion on a theme. Our fellows and members come from across the Academy, but from beyond the Academy as well. Government, business, professionals, startups. Last year, our topic was threats to democracy, which was held in the very week of Trump's election to the presidency. And no doubt many of us have noted an election in the United States this week, or yesterday. This year, we're equally topical. AI, the hope and the hype. It's been convened by the redoubtable Professor Sally Cripps, who not only brings her own enormous expertise, but her extended network of colleagues who are going to be speaking with us today. In fact, what happened was when we had this idea of artificial intelligence, we put together a committee to organise the event. And it was about 2 months in and a great deal of debate. And Sally said, "This is my area of expertise. Just leave it to me." Now, I suspect she has regretted that very much, but it has been amazing. So I want to welcome you, the speakers, the fellows and members of the Royal Society of New South Wales and of the Learned Academies, fellows of the Royal Society of Arts of London, and also some newcomers. And we've worked very hard to have a new group here, and I do hope that those of you who are new to the Society will consider becoming a fellow or a member, and you'll see there's information about that on your seat. So I turn now to the Governor, Her Excellency, the Honourable Margaret Beazley, to formally open the proceedings.
Thank you, Christina. Welcome back, many old friends. Sorry, many friends. I'll take the word old out. It's an old institution, but I didn't refer to the members. But those of you who are our frequent guests here, you know that it is my tradition as Governor here in New South Wales to honour our traditional owners in their language. Pujuri Gamarua, Dian Babana Gamarada. We are on Gadigal land, and I pay my respects to their elders, past, present and emerging. And I wish to echo Christina's words, and I think following on from Susan's leadership and the leadership before that, every organisation of some age needs to always keep an eye on renewal, but not only renewal, but vibrancy within the renewal. And certainly in this very honoured position I've had for the last 6.5 years as being your patron, I have seen that, and I again want to say thank you for taking up one of the things I wanted to do as Governor, which just fitted with you so well, was our concept of ideas at the House, because people are so interested in ideas. We have such a knowledgeable population, and it is so wonderful to be able to bring to as many people as we can those ideas. And I particularly wanted to congratulate you for keeping the online sessions going, which makes these sessions and our ideas at the House sessions continuously available. I have one complaint only, and that is, with all your emphasis on AI, you haven't been able to, and I think this is a quantum computer problem, at least Michelle Simmons tells us she can solve it through quantum computing. You haven't fixed up the traffic. The official secretary is still somewhere between Annandale and Rozelle. I assume he will make an appearance at some time during the course of the day, but what time I can't promise. This is obviously one of the most fundamentally important topics of our time. What AI can tell us: is it a hope? Is it a hype? Is it a nuisance? Is it dangerous? Would it really change our lives? Most importantly, will it really change us as people? Which I think for me is one of the most fundamental questions. I'm not a scientist, I'm a lawyer. What do lawyers do? They try to find a definition. So I start with the question, how does one define AI? And as AI evolves at what I think can be called an unprecedented pace, that definition is also evolving. Indeed, in recent years, the Organisation for Economic Cooperation and Development has struggled to reach consensus on a definition, acknowledging that there is no clear red line, but a continuum of features characterising what we think of artificial intelligence and where the magic happens. Its current, which is the 2023 definition, a definition which the Australian Government's Digital Transformation Agency has adopted, is that AI is a machine-based system that, for explicit or implicit objectives, infers from the input it receives how to generate outputs such as predictions, content recommendations, or decisions that can influence physical or virtual environments. It notes that different AI systems vary in their levels of autonomy and adaptiveness after deployment. It sounds like the manual for one of those, sort of supersonic jets, but that's how we in Australia define AI. AI's applicability and its transformative potential in a seemingly endless range of environments, from governance to science and engineering, medical research, even law, although it's had its problems there, as many of you would know, through hallucinations, problem for lawyers generally, education, health, and the public and community sectors. And it's matched by extraordinary commercial investment. McKinsey forecasts that an astonishing $7 trillion in global AI investment over the next 5 years. It has fueled expectations of governments, with the Australian Government's Productivity Commission forecasting growth of $116 billion in gains over the next decade, and a 4.3 percentage boost in labour productivity. I think, again, for the Australian economy, that is a vital indicator. The next decade is going to be interesting in Australia. We also know that AI has fueled an industry of new AI scholarship with an incredible, this is wonderful, this is really wonderful. So we're talking about AI, and currently there are 403,897 books, journals and papers published worldwide in 2023. So we still haven't lost the power of the printed word, which is my go-to, if I can put it in those terms. A quick old age Google search of the range of recent media articles about AI, noting that AI relies on patterns and thus historical rather than current data, threw up some arresting headlines. And I just quote the headlines. Australia's culture of AI-powered innovation. Another headline, how AI falsely named an innocent journalist as a notorious child murderer. The next one, the Sydney Hospital using AI to improve diagnoses under pressure. I'm not sure what the pressure was, but Big Tech deploys Orwellian doublespeak to mask its democratic corrosion. AI can help the environment, even though it uses tremendous energy. Another challenge, particularly here in Australia, and particularly on our east coast. Tech billionaires seem to be doom prepping. Tech billionaires seem to be doom prepping. Should we all be worried? And the last one is this. Over 50% of the internet is now AI slop, new data finds, with the intriguing subline, humans aren't finished yet. All of which led to another editorial to lead with a lament, can we just have one day with no mention of AI? But that's not today. It then went on to quote a recent Gallup poll in the US, which showed that 49% of people think AI is just another tech advance that will improve our lives, and 49% think that it will harm humans and society. Australians are less inclined to sit on the digital fence. A Snap Roy Morgan SMS survey of 18,000 Australians in early October revealed that 65% of us believe that artificial intelligence creates more problems than it solves, compared to 35% who believe it solves more problems than it creates. So quite a significant divide. On any measure, artificial intelligence can be a polarising topic. It has entered our public discourse not only as a technological innovation, but as a social force, one that promises to reshape the way we learn, work, govern, create, and even imagine what it means to be human. Indeed, we should remember Alan Turing, who, back in 1950, pressed the question, can machines think? On one hand, we hear of AI's capacity to help solve some of our greatest challenges, climate change, diseases and medical conditions, resource scarcity. On the other, we are reminded that technology has often outpaced regulation, and that many promises may remain, at least in the near term, unfulfilled. This duality, the hope and the hype, underscores the tension that societies around the world now grapple with, how to harness AI's enormous potential while guarding against its risks. The question arises, who is leading whom in intelligence? Who imagines the future? Even more importantly, who has the power? And where is the equity? Noting that AI algorithms need big data sets to learn from, but several cultures and groups of the human population are absent or misrepresented in current existing data. As a paper published by the new insecurely funded US National Library of Medicine has pointed out, AI is thus prone to reinforcing bias, which can lead to poor or fatal outcomes, or entrenching disadvantage. All of this has led the European Union to legislate the EU AI Act, the first comprehensive regulation on AI by a major regulator anywhere. So over the course of today's sessions, AI in the law, in communities, in health, AI in practice, and AI research and future directions, these questions will be probed. So let us hold in mind a few guiding principles. Use evidence over assertion. Prioritise ethics, justice and human rights. Factor in governance and oversight. Reflect on interdisciplinarity and humility. And don't forget the need for continuous assessment and adaptation of our legal, regulatory, educational frameworks. AI is a shared responsibility, and forums such as this are essential. They bring together the broad spectrum of expertise needed to ensure that our collective intelligence keeps pace with our artificial one. As more than one academic has pointed out, we're still in the early stages of this history, and much of what will become possible is yet to come. This wonderful Royal Society of ours, the oldest learned society in the Southern Hemisphere, has always stood for rigorous, open, cross-disciplinary dialogue. That tradition is alive today in this gathering of our wonderful scientists, our policymakers, our ethicists, and our industry leaders. And I've mentioned that in the law, the AI has been quite renowned for hallucinating, dredging up cases that never existed. For example, if it does it in the law, and that can be caught out fairly easily by checking up a reference point, where is the danger in terms of particularly medicine and diagnoses? And let me put in this one personal reflection. You know, the habit that one at a certain age gets a little late at night of just scrolling and scrolling. I was engaged in that activity one night, and there was Dr. Karen Phelps on my screen. I think everybody in this room would know Dr. Karen Phelps. She was once, I think, the president of the AMA, a leading doctor in our community, and she was talking about diabetes. I'm starting to read, and there she is, full face, words and mouth completely in sync, unlike so many broadcasts that we look at. And then she started talking about, this became, the treatment of diabetes became really a personal matter for her, not just for her clients. And I'm looking at this and I'm listening, watching with, vaguely open eyes. And then she said, this became very personal to me when my husband was diagnosed with AI. And then there's a picture of her walking with her husband. Now, Dr. Phelps is an openly gay woman in an openly gay, I think, married relationship, but she doesn't have a male husband. This was a total fake. And it was just readily available. People believe this stuff. So there is a challenge. I was watching it to start with to hear what Dr. Karen Phelps was saying about diabetes because I respect her opinion on things. And if I hadn't known her, I don't know her personally well, but I know her personally. I know her and very familiar with her work. I think that to me was particularly scary. So thank you for everyone here today who is here to listen, to learn, to contribute to what is with us, there is no doubt about that, but is a fundamentally important topic. And so therefore, it's my great pleasure to declare open the 2025 Forum of the Royal Society of New South Wales and the Learned Academies, AI, the Hope and the Hype. Thank you.
Thank you, Your Excellency. A characteristically broad-ranging and wise talk. I should say that I have now heard Her Excellency talk on many, many different issues, and she brings scholarship and wiseness and wisdom to us. And I think those principles are ones that are really worth our while thinking about more seriously. I'm now turning to Sally Cripps, who's the convener of today's forum. You'll see in your booklet the list of enormously long and impressive list of Sally's achievements. I wanted to say that one of the things that I think is most exciting about Sally's work is that she's working in a very highly technical area, enormously specialised, and yet she's managed to work across a whole range of issues, looking for global impact. Her concerns and her interests are about global impact. So I'm delighted to introduce her as the chair of the forum now.
Well, thank you for those very kind words. It's really a pleasure to be here with you. So, as we've heard today from the Governor and from the President, we really are at a crossroads of grand hopes and rampant hype. We heard the Governor, who's also stolen some of my statistics, I was going to say, talk about the extraordinary investments that we have going on in AI. We've McKinsey, as was mentioned, forecasting a $7 trillion in global investment, and in the last 2 months, we've had NVIDIA announce a $100 billion investment in OpenAI, and just couple of weeks ago, we've had Google announce a $15 billion investment in India in setting up an AI data centre. So really, there is a huge amount of optimism. Australia has moved in line with this optimism. We have gone from being quite cautious about AI to seeing perhaps the looking at it as a game changer for productivity. And the UK has also shifted in this narrative. But I would like to offer a really cautionary note about this productivity gains, which is there was a recent Nature article which looked at 59 countries and had a look at where those gains in productivity go. And the more developed the country is, the more likely those gains are going to go to profits and not to wages. What that means is that the income inequity, or just in general wealth inequity, is exacerbated or can be exacerbated by new technology such as AI. And I think this is a real challenge for politicians to recognise and stop talking about it as if everybody is naturally going to share in it. Everybody could naturally share in it, but only with action, deliberate action on our part, will that happen. Economists have sounded a further warning. This may be less transformation than hype, with one arguing that's only about 1% of increase to global GP over the next decade. Markets are wobbling, and the AI, the Hope and the Hype Forum, what we seek to do is to explore this tension between, the boundless excitement of hype and hope, which is, to my way of thinking, grounded optimism shaped by governance, ethics and fairness. So as you see up in front of you, the AI panic is here. I don't think it's a panic. And I'm hoping today we'll draw that out. And we're going to draw it out by having a look at various aspects of AI. So the first one is the law, the second is communities, the third is medicine, then in practice, and finally, wrapping it up, will be what the future of research is in AI. So these are the 5 things that we're going to be looking at today. And Christina said, I said, leave it to me. And actually, what I did was ask some really remarkable people and left it to them. And so the people you're going to hear talking today, the people who are on the panels, they have all come together to do this. And I'm so forever grateful for all they're doing. I actually just picked up the phone and said, hey, what do you think? And they ran with it. So I'm really grateful. So I did want to say just a couple of minutes about AI, because there's so much confusion. Today, we're going to be hearing about all sorts of AI. I'm not going to define AI, but I will give a taxonomy. So generative AI, I think of as, that's what you'll all be familiar with ChatGPT. Fantastic at prediction, so much so that it can write essays. And then there is, probabilistic or causal or inferential AI, which is really about understanding the world. So that's the second type. And the third type I would call adaptive AI, which is that which engages in systems and adaptively learn and changes as it goes along. So they're just my framing. There are many others, but that's what we're going to hear about today. And without further ado, I'm going to introduce our introductory speaker, Victor Dominello. So Victor is a globally recognised leader in public transformation and digitalisation. He's listed as in the top 25 innovative government innovative leaders. Most of you here will remember Victor as a Minister for Customer Service, and most of you, I presume, I know what at least the statistics tell me, 85% of us have done it. We've all got our driver's licence on our phones. This was all led by the wonderful Victor Dominello. So he's a superstar, and so without any further ado, I'll ask Victor to give the introductory talk.
Oh, well, thank you very much, Sally. It's actually 87% with a 93.6% satisfaction score. But, what's a couple of decimal points between friends? Thank you, Your Excellency, for that amazing introduction. Today, I'm glad you put the and, not the or, between the hope and the hype. But everyone talks about AI. Like I've been fortunate enough since leaving politics and government 2.5 years ago to be all around the world, from the White House to Mongolia. And even in places like Mongolia, they're talking about some of the things that we've done here in New South Wales, particularly through the Service App. Because what we did here in New South Wales through that service transformation was really government 3.0. Now, I'll just walk you back. Everyone talks in every boardroom I go to, in every government department I talk to, they're all talking about AI. Everyone's talking about AI and the evolution of AI. Where is it going? You got Grok 2, Chat 3, Claude 4, Gemini 5, and as Sally has identified, that's just one stream of AI. Everyone's talking about the various stages, as you do. We talk about the evolution of connectivity. Last decade it was 2G, now, and then 3G, now we're in 4 and 5G. Next decade it'll be 6G, right? There are stages, there are gates. No one is talking about the evolution of government. Because if you don't talk about the evolution of government, then government stays this rock-type figure that becomes reactive rather than proactive. And in the age of AI, that's moving so fast, that is like oil and water. It's not going to mix. Governments have to evolve. They have to become more agile and have to move a bit faster. Just a bit faster would help. If I could walk you through the stages of government evolution and then maybe address where I think the hope and the hype is, and then sit down. The stages of government, think about if you were to distill government, ultimately what's its interface with people, with the citizens, the customers it serves. Now I say customers because it also provides services to refugees who are not citizens, to tourists who are not citizens, to businesses who are not citizens, to visa holders. So when it's dealing with or providing services to organisations, people, communities, how does it interface? It doesn't get a Ouija board out and say, I wonder what Her Excellency's wanting to do today. It normally interfaces through a form, right? If you want to receive a grant, you're going to have to fill out a form. Even if you have to pay money to tax, you've got to fill out a form, right? If you want a driver's license, fill out a form. That's the interface. Up until 1990, we were government zero. That's the paper form. That was the interface for many, many years before that. In 1990, a big meteor hit the planet. It was called the internet. And we went from, and it hit every government around the world, we went from paper form, government 0, to web form, government 1.0. Right, so we're still communicating via forms, but now we also had a web form that we could do 24/7, when we're at the beach, but still in very siloed structures, still pretty much one-way traffic. The government basically requesting information. There wasn't much engagement. 15 years later, about 2005, another big meteor hit the planet. It was called smartphones, social media. We went to the platform era, government 2.0, and that means we've got mobile apps, and we're starting to have a bit more engagement with the customer. And now we're starting to hear a bit more noise around social media. They like these services, they don't like those services. But still very siloed, right? Health does its piece, education does its piece, transport, police, they all do their thing. 15 years later, another big meteor hit the planet. It was called COVID. And then you bring in AI with that, on the heels of that. COVID forced governments all around the world to go to uniform. Think about it. In New South Wales alone, if we said to you, we'll get you through COVID, but what you're going to have to do, you're going to have to download a transport app for the border pass. You're going to have to download a police app for QR check-ins. You're going to have to download a health app for the vaccine certificate. You're going to have to download a finance app for your Dine and Discover vouchers. And then you're going to have to call each department if there's a problem on different numbers. There is no way we would have got through it. Uniform doesn't mean it's one, but it means it's a unified experience. All of those things, suddenly one major dominant app, the service app, one major website, we started looking through that lens. That's government 3.0, and that's what service is. It's the beginning of what that could look like. In another 15 years' time, 2035, another big meteor is going to hit the planet, and it's called AGI, however that's framed. It will be 6G. That's definitely going to come next decade. We're going to have a lot more robotics, humanoid robotics. It's going to be an augmented world. As Her Excellency said, now I can't even tell now who's real and who's not. The level of augmentation in the next decade is going to be almost impossible to discern. But it's going to be a fundamentally different world. We might even have the beginnings of quantum in some enterprise level, i.e. that's going to be intelligent government. There's no such thing as intelligent government now. We might have smart departments, but there's no such thing as intelligent government because the left hand doesn't know what the right's doing. What we are finding is that with the private sector, they are moving rapidly into that G3, G4 environment. Governments have gone from G3, which was forced upon them by COVID, and most governments have now gone back to G2, which is siloed, because the empire strikes back. Ultimately, the source of power in government is around authority, the Premier or the Prime Minister, and money, the Treasurer, and things evolve around those two sons. There's no real third son, the CXO, that represents the human, to make sure that we get that horizontal seamless experience rather than the silos. What the challenge for us, particularly as we're talking about the hope and the hype of AI, is how do we get governments to evolve? Because I can guarantee you this, government is the elephant in the room. In every discussion you have, government is the elephant in that room. It could either be a good elephant and remove roadblocks, get rid of regulation and red tape, and let us move faster. It could be a slow elephant, where most governments are, and just sit there and just slow things down. Or it could be a rampaging bad elephant, such as the robo-debt and the like that tramples all over us. So how do we get government to move from bad to slow to good so that we can capture the hope of AI? And I'll end on this note. There are so many things that we could unpack, and I'm sure a lot of the great speakers after me will go through that. But this is the reality. This is the hype. I had my brain MRI'd recently. My beloved mum's got dementia. And as a result, I've now taken on a role of trying to promote brain health. So I thought I'd go and get an MRI. I did that. Spoke to the neurosurgeon, and he's using AI now to slice my brain into 1,000 pieces and find dots that probably wouldn't have been seen before, right? Good bill of health so far, so that's great. But it's just extraordinary listening to these doctors and researchers about how powerful this will be. This will literally be a tool to profoundly reduce suffering. We will have modern tech miracles. The blind will see, the deaf will hear, the lame will walk. With the brain-computer interfaces and everything else that's coming on board. I went to a neurotech conference the other day, and they were talking about neural dust. Forget brain-computer interfaces, neural dust. Like, the world is going to change so fast. But this is the hype. What happens if all that power, all that control becomes centralised? Then all of a sudden we're in a bad, bad place. And Her Excellency was referencing a book about autocracies. We could have corporate autocracies, because autocracies is just about power. And power in the 21st century, as it's always been really, is about data. Who controls your data? So that's another lens that we should probably think about in the hope and hype era. There is so much hope, and it will be realised hope. But equally, there's a lot of hype in terms of, it may not go as we would like it to be, but hype in a negative sense. If we don't get it right, it will be very, very bad. Thank you, Your Excellency. It's been so wonderful to see you again, and thank you for the invitation. And to another superstar, Sally, you're amazing. Thank you very much. Cheers.
Thanks, Victor. We need to work that superstar bit out, so that we can sort of tag. I was going to call another superstar, but before I call him a superstar, I just need to tell you a bit about him. Our next speaker is Pascal, Professor Pascal van Hentenryck. Pascal is the real deal when it comes to AI. He runs the NSF-funded Centre AI for Optimisation, and they're looking at such a range of problems in that, ranging energy, the environment, health, supply chains. He really is across it all, and I know he's going to give us a lovely talk about what he believes AI is and what he has done in that area. So I don't want to take up any more time, and welcome another superstar.
Thank you, Sally, and good morning, everyone. I still feel like a little kid from Belgium. That's where I come from. It's going to be very difficult to follow Her Excellency and Victor and Sally, but I'll try to do as best as I can. So I'm the director of one of the national AI institutes in the United States. We do use-inspired research. And a lot of the things that I will tell you in the second part of the presentation is going to be about what we do in the Institute for actually trying to make a difference using AI. First, I'd like to thank you for the invitation. It's very humbling, and I'm deeply honored to be here today and trying to talk to you. I like, in general, when I talk about AI, to give you some context. And so in 1966, Joseph Weizenbaum, who was professor at MIT, wrote the first chatbot, and it was a chatbot mimicking a therapist. And it was so compelling that people using the chatbot were actually revealing deep secrets about their private lives. And he wrote an entire book that I was forced to read when I was an undergraduate in part of the philosophy class that I took. But it actually got me interested in AI. But this is telling you that this is not a new area. We actually have been looking at AI for more than 60 years. I was part of the first AI summer when expert systems were really the hot topic, and that was a big bubble that bursted. And then we enter a very, very long winter. But typically, in the winter, you do a lot of good work. So that's where we invented most of the technologies, which is the foundation of AI these days. And that's where people at AT&T Labs, Bell Labs at the time, invented convolutional network, which is the core of what is basically used in computer vision. Statistical natural language processing, which is, you can think of it as the core of ChatGPT these days, was invented at the time. So this was a very big move from, grammar-based natural language processing to statistical natural language processing. The core of robotics was invented at that time here in Australia. And all the other technologies like constraint programming as well, which are very trendy now in manufacturing, were also invented at that time. So we are in the middle of a very hot summer for AI right now. And I want to tell you what actually changed, because there are three things that were really important in actually bringing AI where it is today. The first one is data. It's the web, the point that we have access to a very, very large amount, a massive amount of data, of the data that have been produced by humans for many, many years. And this was not the case before. The second thing that I'm sure you are all aware of are GPUs. Now, I heard about GPUs in 1995 because they were used in computer graphics for actually doing video games and so on. But in a sense, the mathematics behind computer graphics and the mathematics behind AI is actually the same. They are the same concept. And this is why GPUs now are so useful for AI technologies. And then the third thing that people typically forget is the democratization of the tools. The big tech, Meta, Google, and so on, actually were very, very good at actually releasing software that make the technology accessible to a very wide range of public, a large number of scientists, and they were able to build the new machine learning models and the new tools that AI is relying upon these days by using these tools. And so this has made a huge difference for the field. This is an example of what happened in 2010. So people at Stanford started building this massive amount of data concerning image. It's called ImageNet. It was at the time a very, very large data set of images. And what happened is the computer vision system got better and better. And in 2015, they started beating humans in actually classifying images. So this progress in having this data set and then the GPUs made the big difference in computer vision. And they started to be used for actually diagnosing cancer, for recognizing the face of people when you board a plane and things like this. At the same time, researchers in recurrent neural network made a lot of progress as well. And this is what was at the core of Siri and Amazon Alexa. It's all about recognizing speech, recognizing language. And it was told by Bloomberg that this was the main commercial outcomes of AI technology up to that point. This is natural language processing. This is the technology that is at the core of ChatGPT these days. It relies on predicting the next word when you see a sentence or the next set of words. And Google made a big contributions to that in around 2018 when they introduced the transformers technologies. And so this is what is used in ChatGPT. It's all about predicting the next word. It's a statistical machine, and I'll come back to that when I'll talk about hallucination and so on. And of course, we got Waymo. If you go to San Francisco, you can take a trip in Waymo. If you go to Atlanta or Phoenix, you can get trips to move from one point to another one using this technology, which once again was invented in the late 80s and beginning of the 90s. Obviously, when people talk about AI these days, they talk about generative AI, the large language models. I won't talk too much about them, but I already mentioned some of the things. I'll tell you what they are good at in a moment. But this is what, the big thing that happened is when OpenAI actually released ChatGPT, that changed the perception of AI, that made AI come to the public awareness. Obviously, we knew about that technology. I don't think any academic would have released that technology. I don't think big corporation would have released that technology, but somehow it got released. One of the things that people have been building now, and this is going to be the future in a sense, is chatbot based on this LLM, on this large language model. And one of the things that they try to do is understand the intention. That's the difference between using a search engine and using a chatbot these days. They try to understand what you are trying to do, what I'm trying to do. And this is not a single tool. This is something that's trying to see, oh, you are trying to do this, I'm going to use that tool. They can do content generation, as was mentioned before. They can do summarization. They can do query answering. They also try to maintain conversations such that they understand what you are trying to achieve. And so this is kind of what the state of the art in some of these technologies. 2025 is supposed to be the year of agentic AI, and Victor actually talked about AI for government. This is one of the promises, actually, of agentic AI. What is agentic AI is actually, if I summarize it in one word, it's automating workflows. When you look at big corporations, including universities, we are really working at a very low level. Where is the data? How do I access this database? The promise of agentic AI is that you are actually looking at what people are trying to achieve. And you are trying to build tools so that that process is automated. People are supported who are actually implementing these workflows. And so this is one of the big promises. It's not yet realized. A lot of companies are trying to make that happen, but it's not as easy as people thought because humans know a lot about the processes that they have automated, and you need to bring that knowledge inside the AI system. So the hype, this is some of the hypes that you see. We won't need any programmers in the next 10 years. I did something really bold this year. I told my students they have projects that they have to implement using programming language and so on, programming languages and so on. I told them, you can use any tool that you want. This was forbidden the previous year. And you know what? The grades don't change. They are the same because the fundamentals are not going to change. You still need to understand what you are doing when you are actually using AI. This is doctors. Are we going to need doctors? My daughter is a pediatric intensive care, and she came to me about 6 months ago saying, "Daddy," she never wanted to know about computer science. She thought that I was working too hard. And 6 months ago, she called me and said, "Daddy, I want to learn about AI because I need to diagnose these kids, and the doctors don't have enough information." And I'll talk about some of the tools later on. But we still need doctors, but we need better tools for them. It was predicted like 10 years ago that there would not be radiologists and that we would have autonomous car everywhere. As far as I know, all the radiologists are still commuting to work and looking at X-rays and MRIs at this point. They will replace lawyers. We'll talk about the law. I can tell you that I don't think they're going to disappear, but they are going to be much more productive. And then teachers, will replace teachers. Again, I think education is going to change fundamentally, but we'll still need teachers. So the role of generative AI is going to be a productivity tool. It's going to improve productivities. And really, this is a quote that I like. And I'll come back at the end of this talk telling you what I think the future is going to be. But this is part of the future. It's got the people with AI are going to be much better than the people not using AI. This is going to be a tool that everybody, essentially should use. AI is still when you talk about generative AI, this is an hallucination machine. Hallucination is not necessarily bad. As a scientist, I have to hallucinate. That's part of my job. But the public has to understand about the concept of hallucination, what these technologies are actually doing so that they can use them properly. So AI at the edge is going to make a big difference. It's going to change the way we educate. It's going to change education. It's going to change the way we learn. It's going to change the way we access knowledge. And some people expressed doubts earlier about knowledge, and I think this is a big concern. But our relationship with knowledge is going to change. It's going to change the way we communicate. This is also something that we need to take care of. And it's also going to change the way every profession is going to operate. It's also going to change the way we think about us being humans compared to machine. And we can talk about that a lot. This is where I think there are a lot of dangers. A lot of people are using anthropomorphism for what the technology can do now. And I can tell you that the technology is very, very far for actually being a human. And so I think these conversations sometimes are somewhat dangerous because we are much more than an electrical system. We are also biological machine, chemical machines, and so on. And when you look at popular books, it's very interesting. When you look at popular books, science fiction books, they are all about talking about consciousness and things like this. So if you read this book, this is actually pretty interesting. I'm also doing the National AI Strategy for the country of Panama. And I want to touch upon some of the issues that you mentioned because of all these dangers, because of all these, how the technology is going to affect knowledge, understanding of how we communicate. I think you need regulation. What we do for the country of Panama is telling how can you actually boost your economy? Where do you have to invest in AI? But we also want to give them a governance framework. How to make the government much more responsive, how to make sure that you have the sandboxes that you can experiment, and so on. So governance and equity is super important. In Panama, you have a very modern city and very rural areas. We have to make sure that whatever we propose to them is going to make sure that equity, we are going to boost every segment of the population. So let me talk about the hope now. And this is going to be very different from what you hear about AI. This is what we are doing in the AI Institute that I'm leading. And in a sense, this is the road less traveled. This is what people don't talk about in the press. But this is where I believe AI is going to make a huge difference. Science. Science is going to be completely revolutionized. You probably have heard about what Google did with AlphaFold. It's actually completely changing the way you can do a structure prediction for proteins. I worked on that topic. I have papers in that topic like 20 years ago. What they did is remarkable. It shortened the time to discovery by about 6 months. They got a Nobel Prize in chemistry for this. It's actually a very it's a right Nobel Prize. They deserve it tremendously. So science is going to change completely. I'll touch about some of these topics later on again. But I want to talk about engineering as well. And what I'm going to do now is telling you a couple of stories that we have in my institute. There are some stories that exist, but there are many others. But these are stories that I know very well. And what I want to convince you is that AI is actually ready to be deployed in critical infrastructure. And not only is it ready, it's going to be the critical component. If you don't have it, you won't be able to manage this infrastructure correctly. And it all comes from the fact that the infrastructure that we are building are getting bigger, and humans have a lot more difficulties in controlling them. And we have to control them in real time. And I'm going to show you examples of that one. But the realities in the field is that this big infrastructure don't change very fast. When you think about a power grid, you don't build a transmission line every day. You know that here in Australia, right? You don't change, you don't put a new key cranes in Port Botany every day. You don't change your, assembly lines very quickly. Those things are very stable. So you end up running the same problems over and over and over again with a lot of data because we have digitalization have accumulated a lot of data. And we are also very good these days to forecast the future. And therefore, we have a lot of forecast data that we can use. As I told you, data is the new electricity. I'm going to show you how we can leverage it. And I'm going to talk about power system. This is one of the areas we specialize into. And this is, I think, a fundamental area for the future. And this is how you run a power system in the United States. It's very much the same in Australia or in Europe. You try to actually decide who is going to generate power for every hours of the next day. That's the commitment of the generators. And then in real time, you have to choose how much they are going to produce. Because to keep the light on, you have to make sure that at any point in time, the generation and the consumptions are equal. And so what you're going to see in the next slide, I can't show you US data, but this is on the French system. But this is like if the US would take over France. I'm not saying this is a good idea. But this is how they would run the system. On the left, you see the energy that is being produced. The big circles are the nuclear generators. They are not at the right place intentionally. You see also renewable energy there in the southwest. On the right, you see the reserve. The reserve are there if something happens, if you lose a generator, if a line is down. And so these things work. So why am I talking about this? I'm talking about this because there is increased volatility and increased complexity these days because of renewable energy, because of batteries, because of the data centers that were mentioned before, because everything is being electrified, and also because you have a lot of things that the system doesn't see because there are solar panels on the roof, there are cars that are being charged. And you don't want this to happen. So this happened in Spain about 3 months ago. They had a blackout for about 24 hours. So what people would like to have now, what the operators of this system want, are real-time assessment platform. They want to run a lot of scenarios very quickly to actually see if there is a risk in this system. But one of these scenarios is 15 minutes. So you have to run your system in like 2 minutes. What are you going to do? And so what we do is we need two things. We need a crystal ball for predicting the future that's predicting what the load is going to be, what the renewable is going to be. And we made a lot of progress in actually forecasting technologies in the last couple of years. And then you need speed. And this is where we take these optimization problems that we have to solve. We use the massive amount of data, and we use machine learning, because machine learning can approximate any function. And then in real time, you have tuned your machine learning model, and you can run it on a CPU and take milliseconds. So essentially what I'm telling you is that what we are doing is that we are taking what we used to do in real time and moving it offline. We are training the machine learning model. The analogy that I can give you is when you do sports, you train your body such that you build this muscle memory. And that's what we are doing here. We are basically building the muscle memory of the critical system such that in real time, it goes really, really fast. But we have to keep the lights on, so machine learning on its own is not sufficient. You have to have this integration between machine learning and symbolic reasoning, between optimization, mathematics, essentially. And so these combinations, that's what you're going to see in the future, these combinations of generative AI, of prediction methods, and the symbolic part of AI that people have been working on for many years as well. And when you do that, you solve the problems, near optimal solution in milliseconds, and you can train these algorithms in about 30 minutes. So what happens to your system when you do that? Instead of taking 15 minutes, you replace every one of the optimization models by these machine learning models, this AI system, and now you're going to take 5 seconds. It's a game changer. We have tools that could not be done 5 years ago, and it can be used for operating your system. 15 minutes, 5 seconds. I'm going to skip this, but roughly speaking, this was the same thing for actually more complex model. We can do that for hydro and batteries, which is going to be very important. You improve the efficiency of the system by 7%. These are billions of dollars. And you can do that again in milliseconds, very, very fast. I'm going to skip this in the sake of time. So I'm going to talk a little bit about logistics and supply chain now. This is a project that we had with one of the largest packet delivery service in the United States. They run thousands of terminals. They send millions of packages every year. And one of the things that they have to do is load consolidation. They have to choose the path that these packages are going to follow such that they minimize the number of trailers, the number of trains, the number of planes. And so you see Atlanta there and the various routes that the packages can take to go to Chicago. No, Atlanta is not on the sea. This is a slide made by students. They wished Atlanta would be on the sea. So the key point there, again, we use this new AI system that I talked about to move from about an hour into 3 seconds. And now we can start automating this, and the planners can actually look at this and say, yes, this is a good plan. No, I need to change this because I know something that the system doesn't know. There are always planners in the loops. Now, this is probably the most compelling applications that we have built. So this is based on, this is a very large supply chain you're going to see in a moment. But they start from the bill of material, the suppliers, the way you build the products. It can be chip, for instance, chip design, the way that the customer demands. And you do that from a very large number of SKUs for an horizon which is about 3 years. So the problems are massive. They're massive scaled. I had never seen problems that large. They have very large numbers, which is very difficult for machine learning in general. So this is a problem in the pharmaceutical industry, supply chain in the pharmaceutical industry. Again, we move from 40 minutes to 3 seconds. For a planner, it makes a huge difference because now they can actually look at different scenarios in real time. This is in the semiconductor industry. It's one of the largest semiconductor factory in the world. This is 2 million variables. Half of them are integers. And at this particular point, again, we move from 40 minutes to about a couple of seconds. I want to talk about this one quickly. This is how fashion is being affected by AI. So this is with a company that we work in Colombia. Typically, so what is happening in the fashion industry is every 6 months you decide what you're going to produce for the next 6 months, what kind of things we want. I mean, this is boring, but what young people want to wear in the next 6 months. And so typically they send people all over the world to actually look at what is happening in Barcelona, in Milan, in Paris, Tokyo, in Sydney, and so on. And then they decide what to build. And so currently they don't do that anymore. They scrape the web. They are actually looking at the fashion shows. They are looking at what the images of people in Paris, in Barcelona, and so on. And then they do price optimization, but not only their own data, but they can look at the web, what the competitors are doing. It's a completely different game. And this requires multimodal learning, using images and text and so on. So I want to talk about healthcare because I think, as Victor has said, healthcare is going to change dramatically. I will have to actually play with this because PowerPoint is not as nice as Keynote, so I have to move this thing.
You're fantastic.
Yeah, very quickly.
Right now, the pathway through a healthcare system for somebody with dementia is a journey. It's a nightmare, just like it is for anybody with any complicated chronic disease.
He's right. This is Dr. Alan Levy, head of the Emory-Goizueta Brain Health Institute.
It's really tragic because most people still get delayed diagnosis, no diagnosis. Rural America, underrepresented minorities, there's such poor access to healthcare that's number one.
So this was from a PBS documentary in the US. I'm part of that at the end of the day, but I'm going to talk about what is happening, and Victor talked about brain health before. In the United States, if you want to have an appointment with a neurologist in the state of Georgia, it takes about 10 months. It's predicted to actually get to 2 years in the next 5 years. So delay care in brain health is brain lost. And so you really need to change the healthcare system. So this is what we are doing. We are trying to look at the workflows and changing them completely. You could do the same for government, for business, the way you run business system as well. It's thinking differently about how you organize care or you organize government. And so what we do is we build, with Dr. Alan Levy, who is a neurologist, a very famous neurologist for Alzheimer's disease and so on, we are building a brain health center. And what that means is that we are using AI technology to do better triage, to do better diagnosis, to do better treatments. And so AI is used in every one of the steps, but there are obviously doctors in the loop all the time. So this is how you do diagnosis, triage. And this is a chatbot for triage, but it's very different from what you would be using with an LLM. You are actually being driven by what is called the test, a CDR test, which is actually looking at various symptoms and trying to diagnose them. But this is still a conversation. We still use natural language processing for doing this, but we are driven by the medical knowledge. And what we send, and this is very interesting, is something like this. So what you see there is essentially the summary of the conversation that the chatbot has with the doctor. But you see, what is very important is when we make a recommendation, we actually tell the doctor, this is why we are making this recommendation. So the provenance of the recommendation is there. I was very lucky to go to Tasmania a few years back, and I was very stunned because in Tasmania, you know where a particular animal is being grown, what grass is being fed, and when you see that particular piece of meat in the US, we exactly know where that particular animal came from. This is the same here. We have the provenance of the data. We know exactly why we are making this decision, and this is going to be super important. I'm going to skip this for the sake of time. So I'm going to finish. I'm going to tell you, I told you stories. There are many more stories. I think one of the things that's going to happen is that we are going to use AI for creativity, designing new drugs, designing new molecules. So this is a project that we have also inside the Institute. How do you build new enzymes? And it's a combination, actually, here it's very interesting, combination of generative AI and Bayesian optimization. We design better aircrafts. So this is, again, using design now and AI for actually generating new ways of thinking about this that were not possible before. We are building new plants by not using the soil, but directly giving nutrients to the roots of the plant, monitoring how they grow, using computer vision, and then using reinforcement learning to actually control the way they look, the way they taste, and the way they grow. And finally, I have one more, I think. Manufacturing is going to change completely as well, and detect defect much more quickly, and integrates with supply chain. The last thing that I want to do is that I love this picture, obviously, about Sydney. Sydney has a very big financial industry. The financial industry is changing very quickly, but there is also a massive risk. Fraud detection has to be taken care. When I work with Panama, this is one of the big recommendations that we are telling them. You need to be on top of this. There is massive data. The transactions are going so fast that you need to counteract, the malicious agents using AI as well. So this is my last slide. So I think the future of X, where X is any discipline, is going to be the future of AI plus X. You will not ask an engineer, you are not asking an engineer if they are using mathematics these days. In 5 years' time, you won't ask them if they are using AI. It's going to be obvious. And it's going to be the same for every profession. And so the future of AI, I believe, the future of X is the future of AI for X. Thank you very much for having me today.
What a fantastic talk. We've got about 5 minutes for questions, so I'm going to throw to the audience and see if there are any questions.
I'm Hadi from UTS. It's very loud. And my question is related to usage of water and also electricity. Jeff Bezos mentioned to solve it, we have to go to space, and using the cold weather in the space, cold, very low temperature, and also sun for 24 hours. So what do you think?
So what is it?
So could you rephrase the question? I don't think we know where the question is in that. Yeah.
Usage of water?
Usage of water.
Yes. Right. Electricity is huge.
Yeah.
So how we can reduce it? Jeff Bezos just suggested go to space and use the very low temperature and also using sun for 24 hours.
Yeah, so I agree that, and this was mentioned by Her Excellency before, right? So that AI is consuming a massive amount of electricity, a massive amount of water, and water is getting really a scarce resource at this point for the Earth. I think what I think, obviously AI can help in actually managing these processes much better. One of the things that you need to think about is how we manage these very large data centers in a much better fashion, how you combine them with renewable energy, how you combine them with batteries, and so on. So people have to start thinking about this. I'm sure, they are thinking about this. Also, how you're actually using the data center itself. This is a big issue, but again, AI can actually help AI there. I also think, to reassure you, that it's my belief that at the level of the large language model, we are going to converge at some point. And we want, actually, the progress is going to slow down tremendously there. Because we already trained them at massive scale. So I don't worry so much about that. I agree that we have to start looking at how we use water, but we also have a lot of other options, which is actually optimizing the way you use these very big machines, and they are very big. But at some point, I think there is not much more that you can train them on compared to where they have already been trained on. Okay? Yes, sir.
Just, yeah, one more question. Yes? You want to?
I can talk very loudly.
Okay.
Thank you. One of the stress points that seem to be happening is deep fakes,
Yes.
particularly in finance.
Yep.
And I'm wondering, what do you see as the future of the solution to this? Because it's
Yep.
concerning a huge number of people. Very smart deep fakes that can
Yes.
exactly simulate
Yep.
people, simulate voices, simulate everything.
Yeah, and I was very happy that Her Excellency actually mentioned that. And this is why I talked about Tasmania. This is why I show you the example in healthcare. I think provenance is the real issue. Everything that's going to be produced, we have to understand what data has been used. It's also what has been used in the process of creating something, and you need to be able to validate that. If there is no provenance, you should not allow the system to actually publish these things. Now, this is an academic answer. There will be we need a regulatory framework to actually do this. But the technology is there to do that. We have to be able to say, this is where this is how this has been produced. This is the data that has been used. This is why you believe this is truthful and trustworthy. And this is kind of, you have a publication where you have essentially the sources that have been used. And if there are points where you don't know, you're not sure, they should be highlighted. Obviously, you need the regulatory framework to do that. I hope people are going to do this.
Watermarks on images?
Yes, absolutely. You just to see this image has been created using this, and so on. And the technology, you can do things like this. It's possible to do this from a technology standpoint. So it's a great question. I hope, I'm glad that I could answer it, because it gives you a sense that the technology is there, but you need the regulatory framework to do that.
Thank you, Pascal. And I know there are so many more burning questions, but in the interest of time, I'm going to have to shut them off. You will be getting a chance with Pascal in the very last session today. So hold those thoughts and you can ask him those questions then. Thank you.